Okay, we're back. Now, we're currently at the shift by one interval, and we have to talk about something that is one of these counterintuitive things. Human beings cannot see electromagnetic energy other than the electromagnetic energy of light, and light has extremely small wavelengths. And other types of electromagnetic energy, like radio waves or 60 gigahertz, have wavelengths that are at the size of physical structures. And what happens when you have a radio frequency wavelength interacting with a physical structure that is of a size close to the wavelength of that electromagnetic radiation? Weird things happen. Things that happen that aren't intuitively clear to humans, because humans cannot see radio waves at those frequencies to see it happening. But here we have piston transceiver 1 with a full alignment of the piston transceiver channel with the E channel of the cylinder wall. And so we have this intuition that you could have the energy of this that's coming across here and coming out at full power, or we could have it at 3/4 power, or we can have it at half power, or we can have it at 1/4 power. And you see it getting smaller and smaller and smaller. So absolutely intuitive to humans that you can increase the power or decrease the power, and it should get bigger and bigger and make more and more power. Unfortunately, the way that we are creating a decrement of power is we are moving this piston inside the cylinder so that the door, in other words, the power output of this piston is always the same. So the way that a decrement of power that is available out here at the cylinder wall interface is because this doorway between the piston metal and the cylinder wall metal is sliding past each other to make a very small doorway. And so we need to go over here to the place where we are showing quantum mechanical effects, and we will we'll turn off the shift by one full interview, and we'll turn on the shift that's showing quantum mechanic effects. And we'll turn off this power, and we'll take a peek in here, and we'll see that we've set this that on the E cylinder wall transceiver opening, the amount of opening available to transmit power from piston transceiver 1, we've made that doorway really small. And over here, we've magnified what happens with the energy output pattern of the power that happens when you make the doorway really small. This is way too big, but I've exploded the size of it so you can see it. What happens is you get bands of places where there is power and places where there's no power, and there is power and there's no power, and these are refraction effects. And if you have this completely crimped off tiny doorway allowing energy to go down through the piston wall and then through the cylinder wall, it's going to show up on the receiving transceiver in this shape of a quantum mechanical effect. And if we go over here to try to put it in place where it's at scale, we're going to look in here at the E level, and we're going to add this transceiver showing quantum effects. And here's what happens is the energy that's coming out for the E transceiver to perceive has this weird shape to it, where there's places where there is power and places where there is power, places where there's no power. And it is not a uniform distribution of power like you see if you had a little more power. And remember, we always have the same amount of power being generated by this piston wall transceiver. The way that the power is getting less is that this doorway size is being diminished, and this is the aperture, and so we have an aperture control of power effect. And the only thing we need to remember on this is if it gets low enough, the portrait of the power distribution becomes one that's governed by quantum mechanics. It's basically diffracted or refracted, and we're going to show what happens with that in the next video.